Welcome to a short video from Collingwood Lighting about the thermal management of LEDs. What we've got here is a small demonstration jig which will demonstrate what happens to an LED when it is not properly thermally managed. So what I've got here is an LED and a nice big aluminium heatsink, and the LED is insulated from the aluminium heatsink by a little piece of plastic. So what I'm going to do in this experiment is I'm going to have the insulator underneath the LED, and I'm going to put this cover over the top of the LED and measure the light output. So this is a white tube which will collect all the light from the LED and give a relative indication of how much light is coming out of the LED on the screen here. So we should now have 0 on the screen as we do. So what I'm now going to do is I'm going to turn on the LED, and what I'd like you to do is to observe the light output on the meter here at the front. So when we turn it on, immediately you can see 400 plus is the reading, and already you can see the reading dropping off rather rapidly. This reading will continue to drop off as the LED warms up. It's an interesting phenomenon, but LEDs, although they don't consume a huge amount of energy, the energy that they do consume is used in a very small area, approximately 1 millimetre square. And this area gets very hot very quickly. And if you don't efficiently remove the heat from this small area, you will end up with the life of the LED and the light output of the LED being compromised. As the LED warms up, you can clearly see the light output is dropping off, but much more importantly than the light output dropping off, the life of this LED is being seriously compromised by not being properly thermally managed. If we have a look at a sort of typical example of an LED replacement lamp, you can see here this LED replacement lamp has got fins around here for the heat to be dissipated into the free air surrounding this lamp. In order to make this into a fire-rated luminaire, put a cover over the top, and what you've now got is you've got an LED lamp inside a steel can where the ventilation for that lamp is significantly reduced. This will cause problems with the life of the LED inside here. So the light output now, we can see, has dropped off to 350. And what we're going to do is we're going to leave that now for another few moments to see where it gets to. Now, after about 5 minutes, the light output's dropped down here to around about 312, 310. So that's a drop off of 35% in the light output from where we started. What I'm now going to do is I'm going to remove the plastic insulator that I showed you earlier on, and we can have a look at what happens to light output when we remove the insulator from between the LED and the heatsink. So you can immediately see that the light output is starting to increase, and this will increase back up to very near to the starting point if we wait for a couple of moments, a couple of minutes. And I think this clearly demonstrates the importance of proper heat sinking of an LED. You can see the effect it has on the light output, and the effect that it has on the life is far more significant than the effect it has on the light output. Thank you very much.